A candle flame in your kitchen produces light. A distant quasar burning at the edge of the observable universe produces light. A gamma-ray burst from a collapsing star unleashing more energy in seconds than the sun will release in its entire lifetime produces light. Every one of these photons, the calm ones, the violent ones, the ones so faint they can barely be measured, and the ones so energetic they could shatter atomic nuclei, travels at exactly the same speed through empty space. Not approximately the same speed. Exactly. The photon that just left the flickering candle beside you is racing forward at the same velocity as the photon that has been streaking across the cosmos the 13 billion years. Nothing pushes them, nothing accelerates them. They are never slow, never fast, only this one speed. And the question is why? Before we go any further, if you find this kind of deep exploration fascinating, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it makes a huge difference for me. Also, we're now live on Spotify. The link's in the description if you'd like to listen to us wherever you are. Now, let's begin. Consider just how strange the situation actually is. Every source of light in the universe answers to entirely different rules. A candle flame produces light through a chemical reaction at a temperature of perhaps 1500 degrees. A hydrogen atom sitting in a cold interstellar cloud produces a photon by dropping an electron between two quantum energy levels, releasing a tiny sliver of radio energy. A star like our Sun produces light from nuclear fusion at core temperatures near 15 million degrees. A gamma-ray burst, one of the most violent events astronomers have ever detected, releases photons carrying so much energy that a single one of them could rip a hole through the strongest metals we know how to make. These are not variations on a theme. These are radically different physical processes. The reactants are different, the temperatures are different. The energies per photon differ by factors of trillions. The physical mechanisms could not be more distinct from one another. And yet, the moment each of those processes produces a photon, the photon that emerges is moving at exactly the same speed through empty space. Not approximately the same speed, not statistically similar, exactly the same speed, to as many decimal places as any experiment has ever probed. The photon from your candle is moving at 299,792,458 meters per second. So is the photon from the gamma-ray burst. So is the photon from the hydrogen atom in the interstellar cloud. So is the light from every screen you have ever looked at. In vacuum, they all move at the same speed. There are no fast photons. There are no slow photons. There are only photons, moving. To appreciate how strange this actually is, think about how nearly everything else in nature behaves. Throw a baseball, and its speed depends on how hard you throw it. Fire a bullet from different rifles, and the muzzle velocity varies from firearm to firearm. Push a car from rest, and the speed climbs gradually as the engine does work. Kick a soccer ball softly, and it drifts. Kick it hard, and it rockets. In everyday physics, the speed of a moving thing is a downstream property of how it was set into motion. Different launches, different speeds. That is the rule almost everywhere in nature. Light does not follow that rule. The source of a photon determines a great many things about that photon, but not its speed. This is not a minor peculiarity. This is not a small footnote in the physics of light. This is one of the deepest facts in all of physics. And once you notice how strange it is, the strangeness does not go away. To really see what is going on, it helps to spell out what a light source actually does control, because a source controls a lot. When an atom, a lamp, a laser, or a star produces a photon, that production event fixes several distinct properties of the light, but speed is not among them. The first thing the source controls is the photon's energy. Every photon carries a specific amount of energy, and that amount is set by how the photon was made. An electron falling from a high energy level to a lower energy level in a hydrogen atom will release a photon whose energy exactly equals the difference between those two levels. Whatever that difference happens to be, that is what the photon will carry. A different atom, a different transition, a different amount of energy. A microwave oven produces photons of low energy because the process that generates them, an alternating current oscillating inside a magnetron, makes photons with wavelengths of a few centimeters. A medical X-ray machine produces photons of enormous energy because the process that generates them, high-speed electrons crashing into a metal target, creates photons with wavelengths thousands of times shorter than a hydrogen atom is wide. The source determines the energy. Closely tied to energy is frequency. Every photon oscillates at a specific rate, a specific number of cycles per second, measured in hertz. The relationship between energy and frequency is one of the most famous equations in physics, an equation Max Planck wrote down in the year 1900 and Einstein extended in 1905. Photon energy equals Planck's constant multiplied by frequency. This means that fixing the energy of a photon automatically fixes its frequency. High-energy photons oscillate at very high frequencies. Low-energy photons oscillate at very low frequencies. A gamma-ray photon might oscillate 10 to the 20th times per second, 100 billion times a second. A radio photon might oscillate only a few thousand times per second. And the frequency in turn determines the wavelength, because the wavelength is simply how far the wave travels in one complete oscillation. So the source controls energy, frequency, and wavelength. These are all bundled together. Set one, and you have set the others, and they can vary enormously. Across the full electromagnetic spectrum, from the longest radio waves to the highest energy gamma rays, we are dealing with a range of energies that spans more than 20 orders of magnitude. That is a factor of 100 billion. If a low-energy photon and a high-energy photon were compared as if they were animals, we would be comparing something smaller than a virus to something larger than a whale. The differences are almost absurd, and yet they all move at the same speed. The source also determines the direction of the photon. If a laser is pointed east, the photon comes out heading east. If a bulb is glowing in every direction, the photons come out in every direction. A source picks direction. In the case of a single atom, there is quantum randomness involved. The atom does not deterministically pick a specific direction, but when the photon is measured, it is found to have gone somewhere, and the probabilities of different directions are set by the atom's environment and orientation. Either way, the source is where directional information is imprinted. Once the photon is out and traveling through empty space, its direction is fixed until something interferes. Then there is polarization. A photon can be polarized in different ways, depending on how the electric and magnetic components of its wave are oriented. Some sources produce polarized light naturally. Sunlight reflected off water becomes partially polarized. Laser light is polarized because of how the lasing process works. Light from a fluorescent bulb is largely unpolarized because the many atoms emitting are not coordinated with one another. The source shapes the polarization. So the source controls energy, frequency, wavelength, direction, and polarization. That is a rich set of properties. That is essentially everything a physicist would think to specify about a wave, and still, the source does not control the vacuum speed of the photon. That speed is fixed. It is fixed for every photon that has ever existed, and every photon that ever will exist. This is where most people's intuition breaks down. The natural response is to think that a photon with more energy must somehow move faster. A gamma-ray photon carries trillions of times more energy than a radio photon. Surely, if we hand nature a more energetic particle, it should also move that particle more quickly. Every other massive object in the universe obeys that intuition. Give a car more fuel and let it burn harder, and it goes faster. Give a rocket more thrust, and it accelerates. Give a runner more energy, and they can sprint faster than they can jog. Why would a high-energy photon not simply be a faster photon? The answer is that photons do not use their energy to determine their speed. Their energy determines their frequency. It determines their color in the broadest sense of that word, where they sit on the spectrum. It determines what kinds of interactions they can have with matter, whether they can knock an electron out of an atom, whether they can pass through the human body, whether they can be seen by the eye or felt as heat on the skin. But energy does not translate into speed for a photon. Speed is fixed. Energy varies. These two properties of light are decoupled in a way that they are not decoupled for anything else. Physicists have tested this over and over. In the 20th century, and increasingly in the 21st, experiments compared the arrival times of gamma rays and visible light from the same distant cosmic events. Supernovas, quasars, and gamma-ray bursts billions of light-years away. The reasoning is simple. If higher energy photons travelled even slightly faster than lower energy photons, even by 1 part in a trillion, the extra energy would show up as an earlier arrival after a long enough journey. Any tiny difference would accumulate over billions of years of travel into an obvious delay. Astronomers looked for this delay. They looked in the highest energy photons ever detected from distant sources, up to trillions of electron volts each, and compared their arrival times against lower energy photons from the same source. No delay was found. Whether we look at photons carrying almost no energy at all, or photons carrying trillions of times more, they arrive together, having travelled at the same speed for the same amount of time. There is a second, equally stubborn intuition that also needs to be cleared away before any of this can start to make sense. The intuition is that light must begin at rest and then accelerate up to its speed. When a bullet leaves a gun, it begins at rest inside the barrel and accelerates as gunpowder ignites behind it. And by the time it exits the muzzle, it has reached some final velocity. A ball dropped from a rooftop begins at rest and accelerates under gravity, its speed climbing steadily as it falls. Almost every moving object we know about follows this pattern. An initial state of rest or slow motion, followed by acceleration, followed by some final speed. It feels natural to imagine that light must be the same way. First, the photon exists, sitting still. Then, some process pushes it, giving it a shove. Then, it speeds up. Eventually, it reaches the enormous speed at which we always observe it moving, and off it goes. That picture is wrong from the very first moment. A photon is never at rest. Not once. Not for the shortest sliver of time. There is no phase of a photon's existence during which it sits still. The instant a photon comes into being, the instant an electron drops between energy levels, the instant a nuclear reaction completes, the instant a particle and antiparticle annihilate, the photon is already moving at the full vacuum speed of light. There is no ramp-up, there is no acceleration, there is no transitional stage. 0 to full speed happens in 0 time because there is no zero state to accelerate away from. This is not just a strange fact to be memorized. It is a consequence of what a photon actually is at the deepest level. In relativity, the difference between things that can sit still and things that must always move comes down to a single property: rest mass. Anything with rest mass has a rest frame, a reference frame in which it is not moving. You could, in principle, run alongside it, match its velocity, and see it sitting still relative to you. A baseball can sit on a bench. An electron can be trapped in an electric field. A ball of gas can drift at low speed through the vacuum of space. All of these have rest mass. All of them have rest frames. A photon has no rest mass. There is no reference frame in which a photon sits still. You cannot chase a photon and catch up to it. You cannot slow it down to a stop by running alongside it. You cannot even slow it down by a hair. In every frame of reference, from every possible perspective, the photon moves at the same speed. This is what physicists mean when they say photons live on the light cone, a geometric structure inside the mathematics of relativity that separates the possible speeds of massive things from the single speed that massless things are required to travel at. That may sound abstract, but it has a very concrete consequence. It means there is no such thing as a slow photon. Not slow, not fast. No such thing as a photon with a different speed. Speed is simply not a property that can be varied for a photon, the way frequency and energy and direction and polarization can be varied. Every photon has the same speed, full stop. This is why the paradox is a real paradox. If the source of a photon does not determine its speed, and the energy of a photon does not determine its speed, and the photon does not accelerate up to its speed from rest, then where does the speed actually come from? What sets it? What determines that this specific number, and not some other number, is the number that every photon in the universe obeys? The answer, when it finally comes into focus, is that the speed is not set by anything about the photon at all. It is not set by the source. It is not set by the emission process. It is not set by the medium, because empty space is not a medium in any mechanical sense. The speed is set by something much deeper, by the structure of the field that photons are ripples in, and by the geometry of space and time itself. But before that answer can be laid out properly, one more layer of the surprise needs to be turned over, because the number itself is subtly misleading. 300,000 kilometers per second, or more precisely, 299,792,458 meters per second. It looks like it was chosen. It looks like nature picked a value and stamped it into every photon that ever existed. But that is not what is happening. The number depends on the units we use to measure it. If we chose different units for distance and time, the number would look different. Physicists sometimes work in units where the speed of light equals exactly 1. In those units, light does not race, it walks. 1 unit of distance per 1 unit of time. The universe does not know what a meter is. The universe does not know what a second is. These are human conventions, chosen for human convenience. The physical fact, the invariant, unit-free fact, is that light moves at a specific speed, and that this specific speed is the same for every photon, everywhere, always. The speed of light is more fundamental than the number we happen to attach to it. Let this sink in for a moment, because everything that follows depends on holding the shape of the mystery in mind clearly. We have a class of objects, photons, that can be produced by processes as different as chemical reactions in a candle flame and the head-on collision of subatomic particles inside a laboratory accelerator. Those processes give the resulting photons very different energies, very different frequencies, very different wavelengths, very different directions, and very different polarizations. If you handed a physicist 2 photons, one from a candle and one from a gamma-ray burst, and asked them how those photons compared, they could list dozens of differences. Wavelength, energy, momentum, penetrating power, biological effect, behavior when passing through glass. All of these are wildly different between the two photons. But if you asked the physicist how fast each of those photons was moving through empty space, the answer would be the same. Exactly the same, to every decimal place that has ever been measured. The candle photon and the gamma ray photon are moving at identical speeds. The differences that make them so obviously different photons in every other way do not show up in their speed at all. Speed is where the differences vanish. And this is not a special property of a few kinds of photons. It is universal. Every photon that has ever existed in the history of the universe, from the first photons emitted a few 100,000 years after the Big Bang, when the cosmic background radiation went streaming out through a suddenly transparent cosmos, to the photons emitted by an atom in your own body right now, producing thermal radiation. Every one of these photons moves at the same speed. Same. Exactly the same. That is the paradox in its cleanest form. The universe has apparently decided that there is exactly one speed at which certain kinds of things must move, and that speed does not depend on any of the details that make one photon distinguishable from another. The details of the source drop out. The details of the energy drop out. The details of the wavelength drop out. Only the speed survives, and only one value of the speed is allowed. At this point in the story, the natural instinct is to reach for a mechanism. Surely something must be doing the work of keeping all these photons at the same speed. Perhaps empty space itself is somehow pushing them along at a fixed rate. Perhaps some kind of medium is limiting the maximum speed at which any wave can propagate through it. Perhaps there is a background field filling the universe that provides a universal reference frame, and light is somehow locked to that field. Every one of those instincts is wrong. Empty space is not a mechanical medium. It is not pushing light forward. It is not exerting any kind of force on photons. The idea that space might be a subtle substance carrying light waves the way water carries ocean waves was one of the most influential wrong ideas in the history of physics. An idea that took nearly a century to fully dispel, and one whose fingerprints are still felt in the way we intuitively imagine light. Empty space, we now understand, does not do the work of moving light. Light moves through empty space, but empty space is not the reason for light's motion. There is also no universal reference frame. If there were, then the speed of light would depend on how fast you were moving relative to that frame. You could chase a photon and see it moving more slowly, or run away from a photon and see it moving more quickly. But that is not what happens. Countless experiments have shown that the speed of light in vacuum is the same for every observer, no matter how they are moving. A person standing still measures it as one value. A person in a spacecraft moving at any speed less than light itself measures it as the same value. There is no ether. There is no fixed frame. There is only the invariant speed, present in every possible way of setting up your measurements. So the source does not determine the speed. Energy does not determine the speed. There is no medium doing the pushing. There is no reference frame that light is locked to. And yet, there is a speed. One specific speed, universal, invariant, obeyed by every photon in existence. To answer the question of where that speed actually comes from, we have to change what we are asking about. We have to stop thinking of a photon as a tiny particle with a hidden engine, or a launched projectile with a set velocity, and start thinking about what a photon really is at the level of physics that produced our modern understanding of light. Because the photon is not a bullet. The photon is not a marble. The photon is not a self-propelled traveller crossing space. The photon is a specific kind of excitation of a specific kind of field, and the speed at which it moves is a property of that field and of the space-time the field lives in. That is the shift we need to make. The speed of light is not really a property of light. It is a property of the electromagnetic field and, more deeply, a property of spacetime itself. The photon simply obeys what the field and spacetime demand of it. And once we make that shift, the paradox begins to loosen its grip. To answer the question of what actually sets the speed of a photon, we have to start by giving a proper account of what a photon actually is. Not the popular picture of a tiny bullet fired out of a lamp, not a miniature marble streaking through space, not a self-contained little traveller that carries its own engine along with it. None of those images matches the physics, and none of them will ever explain why every photon in the universe moves at the same speed. The picture we need is different, and it took physicists nearly 2 full centuries of struggle to arrive at it. Everything begins with the idea of a field. A field is the physicist's word for a quantity that has a value at every point in space and at every moment in time. That sounds abstract, but everyone has an intuition for what it means. The temperature in a room is a field. Every point in the room has a temperature. The wind speed across a landscape is a field. Every point in the sky above a valley has a wind velocity. A field is just a rule that assigns a value, a number or a direction or a set of numbers to every location in space and every moment in time. Once you have this idea in mind, the next question is which fields nature actually contains. And it turns out that the universe is not built out of tiny hard particles moving through a passive void. The universe is built out of fields. Fields that fill all of space. Fields that exist even where nothing seems to be happening. Fields that carry energy, momentum, and the potential for disturbance. The particles we know about, electrons, quarks, photons, and all the rest, are not primary objects. They are excitations of these underlying fields, ripples, localized concentrations of energy in a field that otherwise stretches quietly across the entire cosmos. For light, the field in question is the electromagnetic field. And of all the fields in nature, this one has the longest and most well-documented history, because we have been able to measure and manipulate it since before we understood what it was. In the 19th century, physicists were slowly piecing together the connection between electricity and magnetism. Michael Faraday, a self-taught experimenter working with wires and magnets, discovered in the 1830s that a changing magnetic field could produce an electric current in a nearby wire. That result, deceptively simple to state, turned out to hint at something enormous. Electricity and magnetism were not separate forces. They were 2 aspects of the same underlying phenomenon. A changing magnetic field creates an electric field, and, symmetrically, a changing electric field creates a magnetic field. Each one gives rise to the other whenever it changes. To feel how strange this is, it helps to picture what Faraday was actually doing in his laboratory in the 1830s. He had wound coils of copper wire around iron rings. He had connected some of those coils to batteries and others to sensitive galvanometers, instruments that could detect the tiniest electrical currents. And he noticed something that shouldn't have been possible according to the physics of his day. When he closed the switch that sent current through the first coil, the needle of the galvanometer connected to the second coil twitched, briefly, and then settled back to 0. When he opened the switch, the needle twitched again in the other direction. But while the current in the first coil flowed steadily, the galvanometer read nothing. Steady current in one coil produced no current in the other. Only changes did. This was the seed of everything. Faraday had discovered that a changing magnetic field could induce an electric current in a nearby conductor, but only when it was changing. A static magnetic field, however strong, did nothing. Motion, change, variation. Those were what mattered. The universe cared about how things were changing, not just about how they were. Faraday, who had almost no formal mathematical training but possessed one of the finest physical intuitions in scientific history, developed the concept of field lines to describe what he was seeing. He imagined invisible lines of magnetic force filling the space around a magnet, and lines of electric force filling the space around a charge. When the magnetic field lines threading through a coil changed because the magnet was moving or the current in an adjacent coil was starting or stopping, an electric field appeared in the coil, and that electric field drove the current. The field lines were his way of making the invisible visible, and they carried an implicit claim that would later prove revolutionary: that the interesting physics was not in the wires themselves or in the magnets, but in the space between them where the fields lived. James Clerk Maxwell, working in London in the 1860s, took this pattern and made it precise. He wrote down a set of 4 equations, now known as Maxwell's equations, that captured everything then known about how electric and magnetic fields behave. And when he stared at those equations, he noticed something extraordinary. The number was not obvious. It fell out of the equations only after Maxwell rearranged them into a form that showed what a self-sustaining electromagnetic disturbance would have to look like. When he wrote down the equation governing such a disturbance, it took the same mathematical form as the equation for any wave, a specific relation between how the wave varies in space and how it varies in time. And in that equation, one particular combination of 2 constants appeared as the wave speed. The first constant was the electric permittivity of vacuum, a number that describes how strongly electric fields respond to electric charges, measured by carefully studying the forces between charged objects in laboratory experiments that had nothing to do with light. The second constant was the magnetic permeability of vacuum, a number that describes how strongly magnetic fields respond to electric currents, measured by studying the forces between current-carrying wires, again in experiments that had nothing to do with light. These 2 numbers had been sitting in physicists' notebooks for decades, each pinned down independently by careful benchtop measurements. Nobody had ever suspected they had anything to do with each other, let alone with light. When Maxwell combined them in the specific way his wave equation demanded, dividing one by the other and taking the square root, he got a speed. And that speed was, within experimental uncertainty, exactly the speed of light that had been measured by astronomers looking at the moons of Jupiter and by laboratory physicists timing light pulses over long distances. 2 constants describing electricity and magnetism, measured with no reference to light at all, combined to give the speed of light. This could not be coincidence. Maxwell had shown that light was an electromagnetic wave, and that the speed of light was baked into the constants of the electromagnetic field itself. He is said to have written afterward that we could scarcely avoid the conclusion that light was an electromagnetic disturbance of the same kind that his equations described. It was one of the great unification moments in the history of science. 2 apparently unrelated forces, electricity and magnetism, had been shown to be aspects of a single phenomenon, and that single phenomenon carried its own natural wave speed, and that wave speed was the speed of light. The equations allowed for a specific solution, a self-sustaining wave in which a changing electric field creates a changing magnetic field, which creates a changing electric field, which creates a changing magnetic field, on and on forever. A ripple in the field that could propagate through empty space without needing anything to push it, because at every instant it was generating the very thing that would make it continue. Maxwell calculated the speed at which such a wave would travel, and the number he got, from combining two constants that had been measured in completely unrelated laboratory experiments, one involving electric forces between charged objects, the other involving magnetic forces between currents, matched to within the precision of the day the speed of light that had already been measured by other means. There was no way to shake off the conclusion. Light was an electromagnetic wave. It was a self-propagating ripple in the electromagnetic field, and the speed at which it travelled was baked into the structure of the field itself. That was the first great answer to the question of where light gets its speed. The speed of light in vacuum is not a property of the light source. It is not a property of the observer. It is a property of the electromagnetic field. The constants of that field, the ones that describe how strongly electric charges push and pull each other, and how strongly magnetic forces respond to changing currents, combine mathematically to give a specific value of the speed at which any disturbance in the field can travel. That speed is fixed by the structure of the field. Every photon obeys it, because every photon is a ripple in that field, and every ripple in that field must move at that speed. Now, this picture already begins to explain a great deal. If the speed of a photon comes from the structure of the field, and the field is the same everywhere in the universe, then the speed must be the same everywhere in the universe. That is exactly what we observe. If the speed comes from the structure of the field, and the field does not care about what process produced any particular ripple in it, then the speed does not depend on the source. That is exactly what we observe. If the speed comes from the structure of the field, and the field is not a mechanical substance made of anything that can be sped up or slowed down, then there is no way to give a photon a bigger push to make it faster. That is exactly what we observe. But the picture, as stated so far, still contains a lurking assumption that needs to be pulled out and examined. Maxwell and his contemporaries assumed that the electromagnetic field must be waving through something. Water waves wave through water. Sound waves wave through air. Every wave that anyone had ever encountered before was a wave in something, a disturbance in a physical medium. And so it seemed obvious that the electromagnetic wave, light, must be waving through something too. That something was named the luminiferous ether, an invisible, undetectable, all-pervading substance that filled the universe and provided the material in which light waves could propagate. For decades, the ether was accepted as an unspoken necessity. Nobody could imagine a wave without something to wave in. If the ether existed, then light was fundamentally not so different from sound, a mechanical disturbance in a medium moving at a speed determined by that medium's properties. And if the ether existed, it would define a special reference frame. Standing still relative to the ether would be objectively different from moving through it. If you moved through the ether in the same direction as a light beam, you should be able to catch up to the light a little. If you moved against the light, you should meet it a little faster. These were testable predictions. In 1887, Albert Michelson and Edward Morley performed one of the most famous experiments in the history of physics, an experiment designed to detect Earth's motion through the ether. The apparatus they built was a marvel of precision. It sat on a slab of stone that floated in a pool of mercury, so that the whole instrument could be rotated smoothly to any orientation. A single beam of light entered the apparatus, struck a partially silvered mirror, and split into two beams that travelled at right angles to each other along the two arms of the interferometer. Each beam bounced off a distant mirror at the end of its arm, returned to the partially silvered mirror, and recombined with the other beam. Where the two beams recombined, they produced an interference pattern, a series of light and dark fringes that depended sensitively on the exact difference in travel time between the two paths. The reasoning was straightforward. If light traveled through an ether, and the Earth moved through that ether at some velocity, then light going along the arm aligned with the Earth's motion should take a slightly different amount of time to complete its round trip compared to light going along the arm perpendicular to that motion. This difference would show up as a shift in the interference fringes. As the apparatus was rotated, the shift should change in a predictable pattern. Michelson had already estimated how big the effect should be. Given the Earth's orbital speed around the Sun, the fringe shift he was looking for should have been about 4/10 of a full fringe, small but very much within the resolution of his instrument. He and Morley took thousands of measurements. They rotated the apparatus in every direction. They repeated the experiment at different times of day and at different times of year, when the Earth was moving in different directions relative to any hypothetical ether. They looked for the fringe shift with painstaking care. They found essentially nothing. What tiny variations they saw were consistent with the noise floor of the instrument. The predicted effect, the fringe shift that should have revealed the Earth's motion through the ether, was completely absent. It was one of the most spectacular null results in the history of experimental physics, and it was so precise and so carefully reproduced that it could not be explained away. Physicists at first tried valiantly to rescue the ether. Perhaps the ether was being dragged along with the Earth, so that in the immediate vicinity of the Earth there was no relative motion to detect. This idea had its own problems. It conflicted with observations of stars, whose positions shifted seasonally in a way that suggested the Earth was moving through some medium, not sitting still in a co-moving one. Others proposed that objects moving through the ether were physically contracted along the direction of motion in exactly the right way to cancel out the fringe shift. This contraction hypothesis was proposed by George Fitzgerald and later refined by Hendrik Lorentz. It saved the ether at the cost of imposing a strange ad hoc rule that objects mysteriously shrank when moving. And even this rescue could not survive the deeper problems that were beginning to emerge as more and more experiments returned negative results. The result was decisive, in a way that shook physics to its foundations. The apparatus had been sensitive enough to detect a fringe shift roughly 40 times smaller than what the ether hypothesis predicted, and even that tiny margin had shown up as nothing. The precision was overwhelming. Some of the most respected physicists of the era refused to accept the null result at first, arguing that some subtle experimental flaw must be responsible. But repeat after repeat produced the same outcome, in laboratories on different continents with progressively refined instruments. By the turn of the century, the position had become impossible to hold. The ether, if it existed at all, could not be doing what everyone had assumed. It could not be providing the medium in which light waves propagate. It could not be defining a preferred rest frame in the universe. It could not be doing anything that could be detected by any experiment ever devised. At that point, the only remaining conclusion was the one physicists had spent decades trying to avoid. The ether was not there. There was no invisible medium filling space. There was no material substance that light was rippling through. The electromagnetic field was not a wave in something else. The electromagnetic field was the something. This is the point where the intuitive picture of a wave has to be surrendered, because it no longer describes what is really going on. Water waves need water, sound waves need air, but light waves do not need anything to wave in. The electromagnetic field is not a disturbance of some deeper substance. It is a fundamental feature of the universe in its own right, present at every point in space, whether or not anything is happening there. When nothing is happening, the field sits quietly at its ground state. When something disturbs it, an accelerating electric charge, a nuclear reaction, an atomic transition, a ripple forms and propagates outward. That ripple is what we call light, and it moves through space because it is a self-sustaining oscillation of the field, not because anything is pushing it. That last sentence is worth pausing on. The photon is not being pushed. Nothing is doing work on the photon to keep it moving. The photon does not carry a hidden reserve of fuel that it slowly burns as it travels. There is no engine, no propulsion, no invisible hand of empty space nudging photons forward. The photon simply is a self-sustaining ripple, and the electromagnetic field allows exactly one propagation speed for that kind of ripple. So the ripple moves at that speed, not because something forces it to, because that is what a ripple in the electromagnetic field does. That is the mode of existence available to it. To picture how this self-sustaining process actually works, imagine two invisible fields, an electric field and a magnetic field, coexisting in the same region of space, at right angles to each other, both pointing perpendicular to the direction the light is going to travel. Right now, at this instant, the electric field is at its peak strength pointing in some direction, say, upward. The magnetic field is at its peak strength pointing perpendicular to that, say, sideways. But these fields are not static. They are oscillating. And critically, they are oscillating in perfect synchronization. As time advances by a tiny fraction, the electric field begins to weaken. It goes from its peak upward value back down towards zero, and then reverses to point downward. As it does this, it is a changing electric field. And a changing electric field, according to Maxwell's equations, produces a magnetic field. The magnitude of the produced magnetic field is proportional to how fast the electric field is changing. So while the electric field is changing rapidly, a strong magnetic field is being produced. But the magnetic field is also changing because the whole configuration is a wave and the magnetic field is oscillating too. And a changing magnetic field, according to Maxwell's equations, produces an electric field. So as the magnetic field weakens from its peak, it produces exactly the electric field needed to keep the pattern going. The magic is that the two coupling strengths, how much a changing electric field produces a magnetic field and how much a changing magnetic field produces an electric field, are precisely such that this loop closes on itself. The changes in one field are exactly what the other field needs to keep oscillating, and vice versa. The wave is self-supporting. It carries itself forward because at every point along its path, the pattern of changing fields is precisely calibrated to regenerate itself an instant later, a little further along. This is why the wave has a specific speed. If it moved any faster or any slower, the timing of the regeneration would fall out of sync. The changing electric field would produce a magnetic field that no longer matched what the wave needed. The changing magnetic field would produce an electric field that no longer fit. The self-sustaining pattern would fall apart. Only at one specific speed does the whole dance work. That speed is set by the two coupling constants of the electromagnetic field, and that speed is what we call the vacuum speed of light. It is not a speed the wave chose. It is the only speed the mathematics allows. To sharpen the intuition, imagine a stretched string. Pluck the string in the middle, and a wave travels outward toward both ends. The speed at which the wave travels along the string is not chosen by you. You cannot pluck harder to make the wave move faster. You can pluck harder to make the wave taller, or louder, or carry more energy. But the speed at which the disturbance travels along the string is set by the string itself. It depends on the string's tension and the string's mass per unit length. Change those, and you change the speed. But once the string is what it is, the wave speed is what it is. You can make waves of any amplitude, any frequency, any shape, and they all travel at the same speed along the string. The electromagnetic field works in an analogous way. It has constants that describe its behavior: the electric permittivity of vacuum and the magnetic permeability of vacuum. These constants play the role, roughly speaking, of the string's tension and mass. They set the speed at which any ripple in the field can propagate. Change nothing about the field, and every possible ripple, every photon, travels at that speed. You cannot make a ripple travel faster by putting more energy into it. You can make a taller wave. You can make a higher frequency wave. You can make a shorter wavelength. But the speed is set by the field, and the field says one speed and one speed only. But an important difference must not be glossed over. A string is a real material object. It has mass, it has atoms, it has physical extent. The electromagnetic field is nothing like that. The field is not made of tiny particles vibrating up and down. The field is not a fabric stretched across the sky. The field does not have a preferred direction, does not have a fixed reference frame, does not have a substance to it. The field is the primary thing. It is not made out of anything more basic that we know about. It is one of the fundamental building blocks of physical reality. This is why the analogy with a string can only take us so far. A wave on a string still needs a string. A wave in the electromagnetic field does not need anything else. The field is the ground level. And that means the speed of the wave, the speed of the photon, is not derivative of some more basic mechanical fact. It is derivative of the structure of the field itself, and the field is fundamental. This picture, in the language of classical physics, was already remarkable. But there was still one deep gap to fill. Maxwell's equations describe electromagnetic waves as continuous ripples, spread out smoothly in space. They do not describe discrete photons. When physicists in the early 20th century began probing what light actually does at the atomic level, in blackbody radiation, in the photoelectric effect, in atomic spectra, they found that light does not always behave like a smooth wave. Sometimes it behaves like a stream of little discrete packets, each carrying a specific amount of energy. Those packets are what we now call photons. The resolution came through quantum mechanics, and the picture that emerged is even more elegant than the classical one. The electromagnetic field is a quantum field. Its ripples are quantized. They come in discrete units. A single photon is one quantum of vibration in the electromagnetic field. It is not a tiny hard particle. It is not a bullet. It is the smallest possible amount of disturbance that the electromagnetic field can carry at a given frequency. Higher frequency means each quantum carries more energy. Lower frequency means each quantum carries less energy. But every quantum, every photon, is a ripple in the same underlying field, and every one of them propagates at the same speed for the same reason. The field allows that speed and no other for its ripples. This is where the deep answer to our question really begins to take shape. When you ask why every photon travels at the same speed, no matter its source or its energy, the answer is that every photon is the same kind of thing, an excitation of the electromagnetic field. And the electromagnetic field only allows its excitations to travel at one speed in vacuum. The source of a photon determines which frequency of excitation is produced. It determines how much energy the excitation carries. It determines where the excitation is heading and how it is polarized. But it does not determine the propagation speed, because that is not a property that the source has any control over. The propagation speed belongs to the field, not to the source. This is also why the intuition that light might be pushed forward by empty space fails so completely. Empty space is not empty in the sense of being nothing. Empty space is a region where the electromagnetic field is present but not excited. The field is still there. It just happens to be at its ground state, sitting quietly with no ripples in it. When a photon comes into being somewhere in that region, it is not a foreign object being launched through inert vacuum. It is a local excitation of the very field that fills that region. The photon is made of the same field that is everywhere. There is no medium in the mechanical sense. There is nothing pushing. There is nothing to resist. The photon is a self-sustaining ripple in the field, and the field is everywhere. There is another way to see how strange and beautiful this is. Consider what has to happen for an electromagnetic wave to keep going once it starts. At every moment, the wave consists of an oscillating electric field and an oscillating magnetic field at right angles to each other, both perpendicular to the direction of travel. The changing electric field is exactly what is needed to produce the changing magnetic field at the next instant. The changing magnetic field is exactly what is needed to produce the changing electric field at the instant after that. The wave keeps going because each component of it, in the very act of changing, produces the other component in just the right way to keep the whole pattern moving forward. There is no external force needed. There is no fuel. The wave is a perfectly balanced dance between electricity and magnetism, and that dance is what light is. The speed at which the dance moves through space is not chosen by us. It is not chosen by the source. It is determined by how strongly a changing electric field produces a magnetic field, and how strongly a changing magnetic field produces an electric field. Those two coupling strengths, the constants of the electromagnetic field, combine mathematically to give a specific propagation speed. And that specific propagation speed is what we call the vacuum speed of light. This raises a natural question that physicists have wrestled with for over a century. If the vacuum speed of light comes from these two constants of the electromagnetic field, then why do those constants have the values they do? Why not some other pair of constants which would give a different vacuum speed? Why does the universe assign this particular set of values and not some other set? The honest answer is that we do not know. These constants are, as far as our best current physics can tell, simply among the fundamental parameters of nature. They are not derivable from a deeper mechanism. They are not calculated from something more basic. They are measured, written down, and used in every equation that describes electromagnetic phenomena. Our theories tell us that if they had different values, the universe would behave differently. But our theories do not tell us why they have the values they do. This is not a failure of the framework. It is an honest limit of what current physics can explain. Some ideas in modern theoretical physics, attempts at quantum gravity, unified field theories, string theory, and various speculative frameworks, hope to eventually explain why the constants of nature take the values they take. But no such theory has yet been confirmed. For now, the values of the electric permittivity and magnetic permeability of vacuum are treated as given. The speed of light in vacuum, calculated from them, is likewise treated as given. It is the number the universe hands us. Every experiment confirms it. Every theory that describes light uses it. But no theory yet in our possession derives it from something deeper. That is a humbling place to arrive at, but it is also an honest one. We have learned enough about photons and the electromagnetic field to say a great deal about the source of their speed. The photon is not a bullet. It is a ripple in a field that fills all of space. The field does not need a medium. It is itself a fundamental feature of the universe. The speed of the ripple is set by the structure of the field, by constants that appear in Maxwell's equations and that combine to give one specific vacuum speed. Every photon obeys that speed because every photon is a ripple in that field. The source imprints frequency, energy, direction, and polarization, but not speed. Speed is not the source's to give. It belongs to the field. That already reframes the mystery quite a lot, but it does not fully answer the question. Even granting that photons are ripples in a field, and that the field determines a single propagation speed, we still have to explain why that speed is the same for every observer, no matter how they are moving. We still have to explain why massless things are locked to this speed, while massive things cannot reach it. We still have to explain why this particular speed appears not only in equations about electromagnetism, but also in equations about time dilation, length contraction, energy, momentum, and causality itself. The electromagnetic field explains why photons all move at the same speed, but it does not, by itself, explain why that speed shows up as a universal speed limit for the entire universe, for information, for causality, for every kind of influence one event can have on another. For that, we need something even deeper than the electromagnetic field. We need to talk about space-time itself, and about what the mathematics of relativity reveals about the geometric structure that light happens to live on. Because the deepest answer to the question of where light gets its speed is not really about light at all. It is about the shape of the universe, the invariant structure of space and time, and the fact that anything without rest mass is required by that structure to travel at one specific speed. Light does not choose this speed. Light does not earn it. Light does not accelerate up to it. Light simply is the kind of thing that lives on it. The picture of a photon as a ripple in the electromagnetic field takes us a long way, but it does not go all the way. It explains why every ripple in the electromagnetic field must travel at the same speed once the field is in place. It does not explain why that particular speed shows up in physics far removed from electromagnetism, in the aging of moving clocks, in the mass of a stationary object, in the maximum speed at which any influence can travel from one event to another. The vacuum speed of light is not just a property of light. It is stitched into the structure of the universe in a much deeper way. And to see how, we need to leave the field behind for a moment and think about space and time themselves. For most of human history, space and time were thought of as separate stages on which the drama of physics unfolded. Space was the empty container in which things existed. Time was the steady ticking that carried events forward. Everyone shared the same space. Everyone shared the same time. If two events happened at the same moment for one observer, they happened at the same moment for every observer. If two objects were a certain distance apart at a certain instant, that distance was a fact about the objects, not about who was measuring it. Space and time were absolute, universal, the same for everyone. Then, in 1905, Albert Einstein published a paper that changed all of that. He did not do it by proposing something wildly speculative. He did it by taking two things that were already known and asking, honestly and unflinchingly, what would happen if both were true at the same time? The first thing was that the laws of physics should look the same to every observer moving at constant velocity. The same principle of relativity that Galileo had understood centuries earlier. The second thing was that Maxwell's equations, which describe the electromagnetic field, contain a specific value for the speed of electromagnetic waves in vacuum, the very speed we have been talking about. If both of those things are true, if the laws of physics look the same to every uniformly moving observer, And if the speed of light in vacuum is part of those laws, then the speed of light in vacuum must look the same to every uniformly moving observer. That sounds innocuous at first, but its consequences are enormous. Think about what it means for a moment. Suppose you are standing still and a photon flies past you. You measure its speed and get some specific number. Now suppose someone else is racing along at half that speed in the same direction as the photon. Common sense says that person should measure the photon moving at half the speed you measured, because they are chasing it. But according to Einstein, they do not. They measure the photon moving at the full speed, the same speed you measured. And if a third person is running the opposite direction, meeting the photon head-on, they also measure the photon moving at the full speed. Not faster, not slower. Exactly the same. This defies everyday intuition. If you are driving down a highway at 60 miles per hour and another car is driving in the same direction at 40, that car appears to be moving 20 miles per hour slower from your perspective. If it were coming toward you at 40, it would appear to be closing on you at 100 miles per hour. Velocities add and subtract in the ordinary way we expect, but when the moving thing is a photon, this simple arithmetic breaks. No matter how fast you chase it, no matter how fast it chases you, the photon always appears to be moving at the same specific speed relative to you. Now, Einstein did not invent this behavior. Experiments had already hinted at it. The null result from the interferometer we discussed earlier was the most famous, but by no means the only one. Other experimenters across Europe and America had been finding similar puzzles in the behavior of light for years. The evidence had been accumulating. What Einstein did was to take that evidence seriously, refuse to paper over it with rescue hypotheses, and follow it wherever it led. Where it leads is this. If everyone measures the same speed for light, no matter how they are moving, then something has to give. And what has to give is our idea of space and time. They cannot both be absolute. If they were, the arithmetic of adding velocities would work in the ordinary way, and the speed of light would depend on the observer. Since it does not depend on the observer, space and time cannot be what we thought they were. They must be flexible in a very specific way, so that different observers end up measuring different distances and different durations, but always agreeing on the speed of light. This is where time dilation and length contraction come in. When you move relative to another observer, your clock runs at a different rate compared to theirs. Not because your clock is defective, not because some force is slowing it down. Time itself passes differently for you. And distances along your direction of motion are different for you than for a stationary observer. Not because your rulers have shrunk, because distance itself is different for you. These effects are real. They have been confirmed to extraordinary precision, with fast-moving particles in accelerators, with atomic clocks flown on airplanes, with GPS satellites whose orbits require relativistic corrections to keep the system accurate. Space and time are not fixed. They bend and stretch in a coordinated way that ensures every observer, no matter how they move, measures the same value for the speed of light. That last phrase is the key. The speed of light is invariant. It is the same for every observer. It is the one thing that does not change when perspectives change. And once physicists understood this, they realized something profound. The speed of light in vacuum is not really a fact about light. It is a fact about space and time themselves. It is the conversion factor between them. It is the number that tells you how much space corresponds to how much time in the fabric of reality. Hermann Minkowski one of Einstein's former teachers, made this vivid in 1908. He pointed out that space and time, as understood in relativity, are not really separate things at all. They are aspects of a single unified structure, spacetime. Instead of thinking of a three-dimensional space that ticks forward in time, we should think of a four-dimensional structure in which space and time are woven together. Every event, everything that happens anywhere at any time, is a single point in this four-dimensional structure. And the geometry of spacetime is not the ordinary geometry we learn in school. It is a specific kind of geometry in which the speed of light plays the role of a fundamental constant. To see what this means, consider what happens in ordinary three-dimensional space. If you want to measure the distance between 2 points, you use the Pythagorean theorem. The square of the distance equals the sum of the squares of the differences in each direction. Simple. Standard. In four-dimensional spacetime, there is a similar formula for the interval between two events, a kind of Pythagorean theorem for spacetime. But it does not just add up the four differences. It handles time differently from space, and the way it handles time involves the speed of light. Specifically, the time between two events, when combined with the space between them in this Pythagorean-like formula, gets multiplied by the speed of light so that time and space can be combined in the same units. Every star you have ever seen, every laser pointer, every fluorescent tube, every campfire, every flash of lightning that has ever cracked across the sky. In this deep sense, the speed of light is the conversion factor that turns time into space and space into time in the geometry of the universe. That is why the speed of light appears in equations that have nothing to do with electromagnetism. It appears in the equation that relates energy and mass, Einstein's famous equation in which the energy of a stationary object equals its mass multiplied by the speed of light squared. It appears in the equations of time dilation, telling us how much slower a moving clock runs compared to a stationary one. It appears in the equations of length contraction, telling us how much shorter a moving object appears along its direction of travel. It appears in the geometry of the light cone, which defines what events can causally influence what other events. The speed of light is not just something that photons happen to move at. It is a fundamental parameter of spacetime itself, a number written into the geometric structure of reality. Once you understand this, the question of why light travels at this speed starts to look very different. The question is no longer, why does light move so fast? Or, what is pushing light along? The question becomes, given a spacetime with this invariant speed built into it, what kinds of objects can move at that speed, and what kinds cannot? The answer to that question is where mass enters the story. And it is here that we get the deepest reason why photons travel at the invariant speed, while everything else travels below it. Every object in the universe has a property called rest mass. Rest mass is the mass an object has when it is not moving. A baseball has a rest mass of about 145 grams. An electron has a rest mass of roughly 1 billion 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 times less than a single gram. Extraordinarily small, but crucially and demonstrably not zero. Any object with a non-zero rest mass, no matter how small, has a special property in spacetime. It has a rest frame. That is, there is a way of setting up your reference frame in which the object is not moving. You could, in principle, run alongside the object at exactly its velocity and see it sitting still. This is where the geometry of spacetime imposes its first big rule. In the geometry of spacetime, an object with rest mass traces out a path. Physicists call it a world line through the four-dimensional structure. That world line is what we would call the history of the object, moment by moment, position by position. And the geometry of spacetime enforces a strict rule on the shape of that world line. It must be what physicists call time-like. Roughly speaking, this means it must move through time faster than it moves through space. In the language of geometry, the world line of a massive object always stays inside a cone-shaped region called the light cone, a region defined by the invariant speed of light. The light cone is one of the most important structures in relativistic physics. Imagine standing at a single point in space-time, a single event, at a specific location and a specific moment. From that event, you can send out light in every direction. That light spreads outward in space as time moves forward, forming an expanding sphere. In the four-dimensional picture, the surface of that expanding sphere traces out a cone in space-time, the light cone of that event. Anything moving slower than light in every direction stays inside this cone, in the time-like region. Anything moving faster than light would exit the cone into what physicists call the space-like region. But the geometry forbids this for anything with rest mass, because it would require infinite energy. To see why, consider what happens as a massive object speeds up. As it moves faster, its kinetic energy increases. That part is familiar. But in relativity, kinetic energy increases in a peculiar way as the object's speed approaches the invariant speed of light. It does not increase in the ordinary quadratic way we learn in classical physics. It increases faster and faster, without bound. Nudging an object that is already close to the invariant speed, even a hair closer, requires enormous energy, and pushing it closer still requires vastly more than that. And as the object's speed gets closer to the invariant speed, the amount of energy required to nudge it any faster grows without limit. To actually reach the invariant speed would require infinite energy. Not a lot of energy, not an unimaginable amount of energy, actually infinite. And the universe does not contain infinite energy. Therefore, no object with rest mass can ever reach the invariant speed. It can get closer and closer, arbitrarily close, but it can never actually arrive. That is one side of the story. Massive objects are locked below the invariant speed by the very structure of relativity. Their world lines must be time-like. They can move as fast as they like, up to the limit, but never at the limit. Now consider what happens for an object with no rest mass. This is where photons live. If an object has zero rest mass, the same set of equations that forbids massive objects from reaching the invariant speed does something completely different for it. The equations do not forbid a massless object from moving at the invariant speed. They require it. A massless object cannot move at any speed less than the invariant speed. It cannot sit still. It cannot travel slowly. The only speed available to it is the invariant speed of light. Why? Because the relationship between energy, momentum, and rest mass in relativity works out in such a way that a massless object with any energy at all must be moving at the invariant speed. The equations simply do not allow anything else. If a photon had zero energy, it would not exist. It would be nothing. As soon as it exists at all, its energy is non-zero, and the only way for a massless object with non-zero energy to satisfy the relativistic equations is for it to be moving at the invariant speed. Not almost, not approximately, exactly. This is why photons can never sit still. Not because something is preventing them from resting, because the geometry of space-time combined with the fact of masslessness leaves no other option. A photon is required by the mathematics of the universe to move at the invariant speed. It has no other mode of existence. And this is also why a photon does not need to accelerate up to that speed. It does not start out slow and then speed up. There is no phase during which it exists, but is not yet at the invariant speed. The instant the photon exists, the instant an atom finishes emitting it, or a nuclear reaction produces it, or an accelerator creates it, it is already moving at the invariant speed. Because that is the only speed a massless object is allowed to have. There is no ramp, no engine, no push. There is just the arrival of a massless quantum of the electromagnetic field, existing in the only way it can exist, moving at the invariant speed built into the fabric of spacetime. Now we can also see why every observer measures the same speed for a photon. When you move relative to another observer, your reference frame is different from theirs. In relativity, this means the way you slice up spacetime into space and time is different from the way they slice it. What you call now is not exactly what they call now. What you call 1 meter apart is not exactly what they call 1 meter apart. These slicings, physicists call them frames of reference, are all valid. There is no preferred one. But the underlying spacetime is the same for all of you, and the invariant speed of light is a feature of that underlying spacetime, not of any particular slicing of it. When you and another observer both measure the speed of the same photon, you get the same number, because you are both measuring a property that belongs to the geometry of spacetime itself, not to your particular perspective on it. To make this more concrete, consider a specific scenario. Two observers, call them Alice and Bob, pass each other in deep space. Alice is in her ship, floating freely. Bob is in his ship, moving past Alice at a substantial fraction of the invariant speed. Both are careful, competent physicists. Both have identical high-precision equipment. Both agree beforehand that they will measure the speed of a single photon that flies past both of them. The photon arrives. Alice measures it. She uses her own clocks, her own rulers, her own instruments. She gets a specific numerical value for the photon's speed. Bob measures it. He uses his own clocks, his own rulers, his own instruments, identical in construction to Alice's. He gets the same numerical value. Not close, not approximately, exactly the same. But here is where it gets strange. If Alice looks at Bob's clocks, she sees them ticking more slowly than her own. Bob's clocks are not defective. From Bob's perspective, his clocks tick perfectly normally. But from Alice's perspective, time is passing more slowly for Bob than for her. And Bob, looking at Alice's clocks, sees them ticking more slowly than his own. This is not a paradox. It is a direct consequence of the geometry of spacetime. If Alice looks at Bob's ship, she sees it contracted along its direction of motion. Bob's ship, which is a certain length in its own reference frame, appears shorter to Alice. And Bob, looking at Alice's ship, sees it contracted along its direction of motion. The same geometric mechanism produces both effects, in both directions, symmetrically. Now consider what this means for the photon measurement. When Alice and Bob both measured the photon's speed, they used different clocks, ticking at different rates, and different rulers of different lengths. Their measurements of time were different. Their measurements of distance were different. And yet, when they each computed distance divided by time to get the speed, they got the same answer. The differences in their clocks and their rulers were precisely calibrated by the geometry of spacetime to produce identical results for the speed of light. This is not a coincidence. This is what invariant means. The universe is arranged so that no matter how you slice up spacetime into your particular version of space and time, the speed of light in vacuum falls out as the same value. This is what invariant means in relativity. It does not mean constant in the everyday sense. It means the same from every perspective. The speed of light is invariant because it is a feature of spacetime itself, not a feature of any particular observer's measurements, and not a feature that depends on any particular way of setting up coordinates. The observers can disagree about nearly everything else. What they cannot disagree about is the speed of light, because that speed is written into the underlying structure they are all embedded in. And now we can also see why the speed of light is the ultimate speed limit of the universe. It is not just the speed at which photons happen to move. It is the boundary between time-like world lines, the paths that massive objects and information can trace through spacetime, and space-like world lines, which do not correspond to any physical trajectory. If you tried to move faster than the invariant speed, you would not be moving through spacetime in a physically meaningful way at all. You would be crossing into a region where cause and effect break down, where events can happen before their causes, where the fundamental rules of physics stop making sense. The universe does not seem to allow this. Every experiment ever performed has been consistent with the rule that no signal, no object, no influence of any kind can travel faster than the invariant speed. It is not just a rule for light, it is a rule for causality itself. The invariance of the speed of light has been tested to a precision that borders on the absurd. It has been checked in experiments on Earth, in experiments in space, in observations of cosmic events, and in the everyday operation of technology that most people carry in their pockets. Consider muons. Muons are particles similar to electrons, but about 200 times heavier, and they are unstable. They decay into other particles after a very short lifetime. In a laboratory, at rest, a muon lives for only about 2 microseconds on average, 2 millionths of a second, before decaying. Even travelling at nearly the invariant speed, a muon lasting only 2 microseconds would cover only about 600 meters before decaying. Muons, produced in the upper atmosphere by cosmic rays, are created roughly 15 kilometers up. Without relativity, essentially none of them should reach the ground. The numbers do not come close to working. And yet, muons produced in the upper atmosphere are detected at ground level in enormous numbers. How? Because they are traveling at nearly the invariant speed. And at those speeds, time dilation is enormous. From our reference frame, watching the muons streak downward, their clocks are ticking much more slowly than clocks at rest. Their 2 microsecond lifetime, from our perspective, is stretched into a much longer duration, long enough for them to reach the ground before decaying. From the muons' own perspective, of course, they live only 2 microseconds. But from that perspective, the atmosphere is contracted along the direction of motion, and the distance to the ground is much shorter. Either way, the mathematics works out, and the muons arrive, every time, in numbers exactly consistent with the predictions of relativity. Particle accelerators provide even more precise tests. In machines like the Large Hadron Collider, particles are routinely accelerated to within a tiny fraction of the invariant speed, close enough that their kinetic energies exceed their rest energies by factors of thousands. To keep pushing them any faster would require exponentially more energy. The predictions of relativity, that no matter how much energy is put in, these particles will approach but never reach the invariant speed, are confirmed every day, every hour, in every operational shift at every particle physics facility on Earth. And in your pocket, if you carry a smartphone with GPS, you are relying on relativistic corrections at every moment. The satellites of the Global Positioning System orbit the Earth at high speeds, and their onboard clocks, extraordinarily precise atomic clocks, run slightly differently from clocks on the ground. If the effects predicted by relativity were not included in the GPS calculations, positional errors would accumulate at a rate of roughly 10 kilometers per day. Within a week of uncorrected operation, your phone would place you nowhere near your actual position. The fact that GPS works to within a few meters is a daily, hourly, minute-by-minute confirmation that time and space behave exactly as relativity says they do, and that the invariant speed of light is exactly what relativity says it is. Every test agrees. Every experiment confirms. The invariant speed is real, it is universal, and it is stitched into the geometry of the universe at a level too deep to be dislodged by any measurement anyone has yet devised. The light cone deserves a closer look, because it is one of the most important geometric structures in all of physics, and it is the geometric object that enforces the speed limit. Imagine a single event, a single point in space-time at a specific place and a specific moment. From that event, light can be emitted in every direction. As time moves forward, that light spreads outward. In three-dimensional space, it forms an expanding sphere. In the four-dimensional picture of space-time, that expanding sphere traces out a cone. The cone has two parts. The future light cone consists of all the events that could receive a light signal from the original event. Every point in space-time that light emitted from the event could possibly reach. The past light cone consists of all the events that could have sent a light signal to the original event. Every point in space-time whose light could possibly have arrived at the event. Anything inside the future light cone is causally reachable from the original event. A signal travelling slower than light, anything moving on a time-like world line, can get there in time. Anything inside the past light cone could have influenced the event. But anything outside the light cone, anything that would require faster than light travel to reach, is causally disconnected from the event. No signal can cross the boundary. No influence can reach across it. The light cone divides space-time at every event into the reachable and the unreachable. The invariant speed of light defines exactly where the boundary of the light cone lies. If the invariant speed were larger, the cone would be wider, and more of space-time would be causally connected to the original event. If it were smaller, the cone would be narrower. The specific value of the invariant speed is what determines the geometry of causality. It tells the universe how much of the future is influenced by the present, and how much of the past could have influenced the present. Every event in the universe has its own light cone, and every event's light cone has the same angular opening, because the invariant speed is the same everywhere. This is why the vacuum speed of light shows up in so many different equations across physics. It is not because photons keep sneaking into all the equations. It is because the invariant speed is a fundamental feature of space-time, and any equation that describes something moving through space-time will encounter it. Massive particles have their energy and momentum related through it. Time dilation is calibrated by it. Length contraction is calibrated by it. The relationship between mass and energy is set by it. Wherever space-time appears in physics, the invariant speed appears alongside it, because it is the number written into space-time itself. Now we can circle back to the paradox we started with and see how the answer has clicked into place. Every photon in the universe travels at the same vacuum speed because every photon is a massless excitation of the electromagnetic field, and anything massless is required by the geometry of space-time to travel at the invariant speed. The source of the photon determines its energy, its frequency, its direction, and its polarization. But the source does not have any say in its speed, because speed is not the source's property to give. Speed is a property of what the photon is, massless, combined with the space-time the photon exists in. The instant the photon exists, it is massless, and being massless in a space-time with this geometry means moving at exactly the invariant speed and no other speed. There is no other option available anywhere in the universe. And crucially, every observer, no matter how they are moving, measures the same speed for the photon. Not because the photon adjusts itself to different observers, because the invariant speed is a property of space-time, and space-time is the same for all observers. Different observers slice up space-time differently. They disagree about what counts as 1 meter and 1 second. But they all agree on the invariant speed, because that is the number the universe has written into the geometry itself. There is one more piece of the picture worth naming clearly. The invariant speed is not really the speed of light. It is the speed that any massless thing must travel at in vacuum. Light happens to be the most familiar example because photons are massless and we encounter them constantly. But if other massless particles exist, gravitons, for instance, the hypothetical carriers of gravity, they would travel at exactly the same speed. The invariant speed is a property of spacetime, not a property of light specifically. It would exist even if the universe contained no photons at all. It would be the maximum speed for anything, whether or not there were anything moving that fast. The universe was going to have this speed with or without light. Light just happens to travel on it. That is why calling this the speed of light is, in a sense, a historical accident. Physicists sometimes call it the invariant speed, or the speed of causality, or simply the cosmic speed limit. Those names capture the deeper truth better than the familiar phrase. Light is not fast because it is bright. Light is not fast because it is energetic. Light is fast, always at exactly the invariant speed, because it is massless, and because the geometry of spacetime requires massless things to travel at the invariant speed, and because that geometry is the same for every observer, everywhere in the universe. So the source of a photon's speed, at the deepest level we currently understand, is not the source of the photon at all. It is the structure of the field the photon lives in, together with the invariant geometry of the spacetime that field lives in. The photon obeys both. It has to. And that is why every photon in the universe, whatever produced it, is racing along at exactly the same speed the instant it comes into being, and will keep doing so until something absorbs it, scatters it, or otherwise ends its existence. But even this is not the full story, because sometimes light does not travel at that invariant speed. Sometimes it appears to slow down, and that raises questions of its own, which we still need to answer clearly. There is one loose thread from everything we have said so far that needs to be pulled and carefully unravelled, because it comes up almost every time this subject is discussed, and it is easy to get wrong. We have said, repeatedly and emphatically, that every photon in vacuum moves at the same invariant speed. Not almost, not close to, exactly. And we have said that no observer, no matter how fast they are moving, can ever measure any photon in vacuum going any other speed. Fine. But then a curious thing happens the moment you put a piece of glass, or a bowl of water, or a diamond in front of that photon. Suddenly the light appears to slow down, measurably, sometimes dramatically. Light in water travels at only about 3/4 of its vacuum speed. Light in ordinary glass travels at about 2/3 of its vacuum speed. Light in diamond travels at less than half. If the speed of light is invariant, if it is stitched into the very fabric of space-time, and every photon in vacuum must travel at this one specific speed, how is it possible for a chunk of glass to slow it down? The resolution is one of the most beautiful and often misunderstood pieces of optical physics, and it hinges on the fact that a piece of glass is not empty. A piece of glass is a lattice of atoms, trillions upon trillions of them per cubic centimetre, every one of which has electrons that respond to the electromagnetic field. Empty space contains only the electromagnetic field itself, quietly at its ground state. Glass contains the electromagnetic field plus a dense, structured collection of charged particles that are constantly interacting with any ripple in that field. When a photon enters glass, it does not stop being a photon. It does not slow down as a fundamental entity. Between the atoms, in the tiny gaps of vacuum inside the glass, the electromagnetic field still allows only one propagation speed for its ripples, and that speed is the same invariant speed as ever. But the atoms are constantly getting in the way. What happens is this. As the electromagnetic wave passes by an atom, it wiggles the atom's electrons. Those wiggling electrons are themselves accelerating charges, and accelerating charges produce their own electromagnetic waves. So each atom, in response to the incoming wave, emits a tiny wave of its own. That new wave adds to the original wave, and when you add all of these contributions together, the incoming wave plus the re-radiated waves from every atom in the material, the sum turns out to be a wave that travels through the bulk of the material at an effective speed lower than the vacuum speed. The atoms are not slowing anything down mechanically. They are contributing their own secondary waves that, when combined with the original, produce a total wave whose crests and troughs advance more slowly through the material than the original crests and troughs would have on their own. This is called the phase velocity of light in the medium. It is a real, measurable quantity. It is what we mean when we say that light travels more slowly through glass. But it is a collective effect, a property of the whole wave interacting with the whole material, not a slowing of any individual photon in the fundamental sense. The invariant vacuum speed is still doing its work between the atoms. What is slower is the effective advance of the combined wave, once all the re-radiated contributions are added together. There is a useful way to see this in the language of photons themselves. When a photon travels through a transparent material, we can imagine it constantly getting absorbed by an atom and re-emitted a moment later. That imagery is not quite right in the detailed quantum mechanical description, but it captures the important qualitative point. Between interactions with atoms, the photon is moving at the invariant vacuum speed. Its interactions with the atoms introduce tiny delays. Over a macroscopic distance of glass, those tiny delays accumulate into a noticeable overall slowing of the wave. The photon is not fighting through molasses. It is being repeatedly slowed by interactions, and then continuing at the full invariant speed in between. What we measure as the speed of light in glass is an average, a summary of an enormously complicated dance between the electromagnetic field and the atoms of the material. The reason different materials slow light by different amounts comes down to how densely their atoms are packed and how strongly their electrons respond to the electromagnetic field. Diamond is one of the most striking examples. Its carbon atoms sit in an extraordinarily rigid, tightly packed crystal lattice, and their electrons respond powerfully to incoming light across a wide range of frequencies. Every atom contributes a significant re-radiated wave, and the accumulated delay across even a small thickness of diamond is enormous. Water, by contrast, is a liquid. Its molecules are more loosely arranged, and the re-radiated contributions are less intense. Glass sits somewhere in between. There is another subtlety that is worth naming, because it produces one of the most familiar visual phenomena in nature. Different frequencies of light are slowed by different amounts inside the same material. Blue light is slowed slightly more than red light in ordinary glass, because the electrons in the glass respond more strongly to higher frequencies. This frequency-dependent slowing is called dispersion, and it is why a glass prism spreads white light into a rainbow. Each color takes a slightly different path through the prism because each color effectively travels at a slightly different speed inside the glass. The invariant vacuum speed is untouched. What varies is only the composite wave's behavior in matter. This distinction matters because it clarifies what the invariant speed really is. The invariant speed is not the fastest speed light can go under any circumstances. It is the speed at which a ripple in the electromagnetic field propagates through a region of spacetime where nothing else is present. Put atoms in the way, and the collective wave slows. But the underlying rule that a ripple in the field alone travels at exactly this one speed is preserved. This is why physicists are so careful to specify the speed of light in vacuum whenever precision matters. The phrase, the speed of light, without any qualifier, can be ambiguous. In common speech, we mean the vacuum value, the invariant speed. But strictly, once you put light in a medium, its effective speed depends on the medium. There is a striking demonstration of this. Physicists in laboratories have produced conditions using ultra-cold clouds of atoms in specific quantum states, in which the effective speed of a light pulse is slowed to walking pace, to bicycling pace, and in some remarkable experiments, even brought to a complete halt for a fraction of a second before being released and allowed to continue on its way. This is not science fiction. It has been done. But at no point during any of these experiments has any individual photon been moving at anything other than the invariant vacuum speed between atoms. The apparent slowing and the apparent stopping are collective effects of the wave's interaction with the atomic cloud. The invariant speed is intact throughout. What has been slowed is the composite wave, not the fundamental propagation of electromagnetic disturbance through vacuum itself. So light does slow down in materials. That is a genuine and important fact. But it slows down as a wave interacting with matter, not as photons that are somehow tired or dragged. The invariant speed remains what it has always been. Now, having settled that, we should turn to another point that has been quietly sitting under everything we have said, and that we have not yet fully faced. We have been talking about the speed of light, as if it were a specific number, 299,792,458 meters per second, and treating that number as if it meant something absolute. But that number is, in a very real sense, a human invention. Not the physical fact of the invariant speed, but the number attached to it. The number depends entirely on the units we use to describe distance and time. Consider what a meter actually is. Today, the meter is defined by the International System of Units in terms of the speed of light. It is defined as the distance that light travels in vacuum in 1,299,792,458th of a second. So the number 299,792,458 is not a measurement anymore. It is a definition. It is fixed by decree. We chose it because that particular number matched, to the best precision we then had, the older, independent definitions of the meter that had been in use for centuries. First as a fraction of the Earth's circumference, then as the length of a specific platinum iridium bar in France, and eventually as a certain number of wavelengths of a specific atomic transition. When measurements of the speed of light in the older units became sufficiently precise, physicists realized it was cleaner to reverse the logic. Fix the numerical value of the speed of light by convention, and let the meter be defined in terms of it. The universe does not know about that arrangement. The universe has no opinion about the meter. It has an invariant speed, and human beings have chosen units in which that speed happens to have the numerical value it does. If we had chosen different units, the number would look different. If we measured distance in miles instead of meters, the speed of light would be about 186,000 miles per second, a completely different number describing the same physical reality. If we measured time in years and distance in light years, the speed of light would be exactly 1 light year per year. In these units, the speed of light is just 1, not thousands, not millions, 1. The whole idea of light being fast would fall away, because it would be travelling at 1 unit of distance per 1 unit of time, which is not fast. It is simply what light does. Physicists working on relativity, quantum field theory, and cosmology often use exactly these kinds of units, in which the speed of light is set to 1. It simplifies the equations enormously. Distances and times get measured in the same units. Energy and mass get measured in the same units. The invariant speed drops out of the equations entirely as a numerical factor and becomes visible only in its role as the geometric conversion between space and time. In these units, Einstein's famous equation relating energy and mass becomes simply that energy equals mass. Not mass times some big number, just mass, because the big number is 1. This is not a trick. It is a way of stripping the human-imposed numerical baggage off the physics and revealing what is actually happening underneath. The physical fact, the invariant, unit-free fact, is that light in vacuum moves at a specific speed, and that this specific speed is the same for every observer, everywhere, and shows up as the conversion between space and time in the geometry of the universe. The number we attach to that speed is a matter of unit choice. 299,792,458 is not a special number the universe emphasizes. It is a number that happens to fall out of our historical choice of measurement conventions. The physics is in the invariance, not in the numerical value. This raises a question that people often ask at this point in the discussion, and it deserves a careful and honest answer. If the invariant speed is such a fundamental feature of spacetime, and if it appears everywhere in physics, then surely there must be some deeper reason why it has the value it does. Not the numerical value in meters per second, that is just our unit choice, but the underlying physical value. If we asked in dimensionless terms, comparing the speed of light to something else in nature, could we derive that comparison from a deeper principle? The honest answer is that we cannot. Not yet, perhaps not ever. In current physics, the vacuum speed of light is treated as one of the fundamental constants of nature. It is measured, incorporated into every equation that describes the physical world, and used to make extraordinarily precise predictions. But it is not calculated from something deeper. Our best theories take the invariant speed as an input, not as an output. Various proposals in theoretical physics, attempts to unify quantum mechanics with gravity, string theory, various speculative frameworks about the ultimate constituents of matter and spacetime, hope that eventually some deeper structure will be found from which the values of fundamental constants can be derived. But no such derivation has ever been confirmed. Every experiment, every measurement, every prediction stops at the value of the invariant speed and treats it as a given. This is not a defect of physics. It is an honest statement of where the frontier is. Some things in the theory get explained by other things. Some things do not. The vacuum speed of light is one of the ones that does not, at least not yet. It is a brute fact about the geometric structure of spacetime, the number that says how much space corresponds to how much time in the fabric of reality, and we have not found any principle from which it can be derived. It just is. There is also a common misconception it is worth naming directly. People sometimes suggest that photons must be moving at this speed because they carry so much energy per unit mass, or because they are so light, or because there is nothing to slow them down. All of these guesses are wrong. Photons are not fast because they are energetic. A high-energy photon and a low-energy photon travel at exactly the same speed. Photons are not fast because they are light. They have no rest mass at all, which is a categorically different situation from being merely lightweight. And there is nothing slowing them down that has been removed to let them race. There is nothing in vacuum to slow them down at any speed. Photons travel at the invariant speed because they are massless excitations of a field in a spacetime whose geometry requires massless things to travel at that speed. Their energy has nothing to do with it. Their masslessness has everything to do with it. There is one more subtle piece to add before we can put the whole picture together. We have said that the vacuum speed of light is the same for every observer, and that this is a consequence of the geometry of spacetime. But this raises a question of consistency. If different observers, moving at different velocities, all measure the same speed for the same photon, then their notions of distance and time must be different in exactly the right way to make this work out. And they are. Time dilation and length contraction are precisely calibrated so that the invariance of the speed of light is preserved. But this means that the invariant speed is more than just a property of light. It is a property that ties together the way space and time work for every possible observer. It is the fixed point around which all other measurements pivot. Think about that for a moment. Almost everything else you can measure, the length of a table, the duration of a heartbeat, the mass of a moving object, is not the same for every observer. Different observers, moving relative to each other, will measure different values for these things. What each observer measures is real and correct, and consistent with the laws of physics. There is no privileged observer whose measurements are more true than anyone else's. And yet, in the middle of all this relativity, there is one thing that every observer agrees on: the speed of light in vacuum. That is the invariant. That is the anchor. That is the fixed point around which the whole geometric machinery of relativity is built. Now we can put the answer together in its complete form. Where does light get its speed from? The full answer, as best as modern physics can tell us, has several interlocking parts. Light is not a projectile with a hidden engine. Light is a self-sustaining oscillation of the electromagnetic field, a field which itself is one of the fundamental structural features of the universe, present everywhere and needing no medium to exist in. What we call a photon is a single quantum of that oscillation, the smallest indivisible unit of disturbance the field can carry at a given frequency. This is what light is at the deepest level our current physics can describe. The vacuum speed of any ripple in the electromagnetic field is fixed by the structure of the field itself. Two fundamental constants of the field, the electric permittivity of vacuum and the magnetic permeability of vacuum, combine to determine a specific propagation speed. This is a property of the field, not of the source of any particular ripple. This is why every photon, no matter how it was produced, must travel at the same vacuum speed.
But the deeper reason that speed is the same for every observer and shows up throughout the rest of physics is that photons are massless excitations, and the geometry of spacetime requires massless things to travel at the invariant speed. Massive objects can move at any speed below the invariant speed, but never at or above it, because reaching it would require infinite energy. Massless objects cannot move at any speed other than the invariant speed, because the equations relating energy, momentum, and mass in relativity leave no other option. The instant a photon exists, the instant a massless excitation of the electromagnetic field comes into being, it is already moving at the invariant speed. There is no acceleration. There is no ramp. There is no starting from rest. The photon is required by the mathematics of the universe to travel at exactly this one speed, and no other. Every observer, no matter how they are moving, measures the same speed for that photon, because the invariant speed is not a feature of any particular observer's perspective. It is a feature of the geometry of spacetime itself. Different observers slice spacetime into space and time differently. They disagree about durations, about distances, about simultaneity. They disagree about what happened first and what happened after, about which of two events was closer and which was farther, about how fast someone else's clock is ticking. But they all agree on the invariant speed,
because that speed belongs to the underlying geometry, not to any particular way of slicing it up into space and time. The specific number we attach to that speed depends on the units we chose long ago for measuring length and time, but the invariance itself does not care about our units. It is a structural fact about the universe. Whatever unit system you use, whatever civilization does the measuring, whatever galaxy the measurement takes place in, the same geometric invariant is being reported. The number varies, the fact does not. Light appears to slow down in glass or water, not because photons themselves slow down, but because the collective wave that we call light is the sum of the original wave plus the re-radiated waves from every atom of the material. This composite wave advances more slowly than a wave in vacuum would. Between atoms, in the empty spaces of any material, photons are still bound by the invariant speed. The slowing is a phenomenon of the whole wave in the whole material, not a phenomenon of any individual photon. And the invariant speed is not really the speed of light in a fundamental sense. It is the speed at which any massless thing must travel. It is the boundary between what can causally influence what. It is the maximum speed at which any signal, any object, any influence can propagate through the universe. Light happens to travel at this speed because light happens to be made of massless particles. If there were no photons in the universe, this speed would still exist. It would still be built into the geometry of space-time. This speed would exist even in a universe with no photons at all. It is not the photons that make it real. It is the geometry. That is where light gets its speed. Not from itself, not from its source, not from the medium it moves through, not from some hidden mechanism giving it a nudge. Light gets its speed from what light is, a massless excitation of the electromagnetic field, and from the geometry of the space-time in which it exists. The speed is not something the photon does. It is something the photon is subject to, the moment it comes into being. Every photon that has ever existed, from the first light of the early universe to the light bouncing off the page or screen you are looking at right now, has been moving at exactly the same invariant speed for exactly the same reason. It was massless. It was in this space-time. It had no other option. And in a very deep sense, that is the whole answer. Light does not have to be pushed. Light does not have to accelerate. Light does not have to obey anything more mysterious than the geometry of the universe itself. The speed of light is the speed of the universe, the number that tells you how much space corresponds to how much time. Light rides on that number because it has no mass to hold it back, and every observer, everywhere, at every moment, measures the same speed for it, because they are all looking at the same underlying geometry from different angles. The universe has an invariant speed. Massless things must travel at it. Light is massless. That is where light gets its speed. Not in some hidden mechanism, but in the deepest structural features of space, time, mass, and the fields that fill the cosmos. And that is a remarkably elegant answer, once the strangeness has settled into place, that the answer to one of the most striking mysteries in physics is not that light is doing something special, but that the universe, from the ground up, is built in such a way that light simply cannot do anything else.